Good morning, everyone. Noting the time, I am what stands between you and lunch, so I'm going to do my absolute best to make sure that we end on time for lunch. But thank you very much for inviting me today to present. My name is, as he said, Robin Zevotek. I'm a principal fire protection engineer at the National Fire Protection Association in the U.S., and I'm going to share a little bit different perspective than Wojciech, who eloquently pointed out the problems, but we have to start somewhere to decide how we're going to address these problems. And in the US, we're very prescriptive-based code for these. And I took a look at applying our prescriptive-based codes to these new challenges to see how they at least provide a starting point. Are they perfect? No, but as we talk about some of these today, we'll see that it was very obvious in some of these larger loft fires, we didn't even start at the baseline to be able to allow us to go forward. So we're going to talk about the fire hazards of sustainable building and just the NFPA perspective to that. So what is NFPA? This is a very confusing thing as well. 125 plus years ago, we decided we were going to be called the National Fire Protection Association, which assumed that we were national, meaning subsidized by the government of the U.S. We are not. We are a global nonprofit. So although our title calls us the National Fire Protection Association, we are self-funded by the sale of our codes and standards that we develop. We're established in 1896, mainly focused around how do you best install fire sprinklers. So in the area of Boston in the US, there were many different ways to install fire sprinklers. And it was seen that some were very, very effective and others were less effective. And if we put together a standard that looked to capture the most effective means, then the sprinkler systems were incredibly effective. So they were able to publish a standard, NFPA 13. I'm sure some of you have heard of it. And that still exists today as one of the premier ways to install sprinklers. Our original objective was to have those sprinkler systems and installed in a consistent manner. But as we looked at the fire problem throughout the world, we looked at it more as a knowledge problem than as a codes and standards problem. So how do we provide knowledge to address the fire safety problem? We do develop codes and standards. It's an incredibly costly process to do. And we sell those codes and standards to be able to continue that development. We have more than 300 codes and standards, and we have over 275 technical committees. So what are those technical committees? Those are folks that volunteer their time to sit on these committees to develop what we consider a consensus standard. So something where all parties have had equal input into the standard to develop at least a baseline for the best way that you could accomplish something. Is it always perfect? Absolutely not. Is it always modern? Absolutely not, but it's at least a baseline to start with. We also do training and certification, so we offer 17 individual certifications and a whole bunch of online trainings, as well as an entire research arm, the Fire Protection Research Foundation, which is a separate nonprofit, which kind of informs our codes and standards. So what do I want to talk about today? We're going to look at some of these sustainable building topics: tall wood buildings, photovoltaic systems on buildings, energy storage systems, and combustible facades, and how at least the currently developed codes and standards look at these things. Then we'll take a quick look at that standards development process and one little case study on how this could go a little awry. And then we'll look at a concept that was developed several years ago called our fire and life safety ecosystem, which looks at more of a holistic approach rather than just the codes and standards approach to how we can have a fire safe world. So, tall wood buildings. The Fire Protection Research Foundation did a study on tall wood buildings, looking at how these wood compartments or taller wood compartments behaved under fire conditions. And out of their report, there were some main safety concerns. The first one was the stability. So the materials itself were an issue as they delaminated, and as well as the connections where the materials connected together were a challenge. There was also this contribution to the fire load, which Wojciech pointed out incredibly when you talk about the furnace tests. They don't need to pump as much gas into the furnace test because the wood itself provides some of the energy needed to keep the fire temperature of the furnace together. In our codes and standards, NFPA 220 is the standard on types of building construction. And this building construction of wood or laminated wood or cross-laminated wood has been around for a considerable amount of time. We consider it a Type 4 building. In the US, they were very common for actually farm areas, for barns, and a lot of factories were constructed with these tall mass timber building wood. So the Type 4 construction isn't necessarily new, but the building code, or at least NFPA's building code, limited the height of these buildings because it was known to be a challenge. So they limited them to 26 meters. And depending on what was going on inside the building, so the occupancy, they could be between 2 to 6 stories. And that's still in the code today. If you were interested in getting to an unlimited height area building, you needed to move into a Type 1 or a non-combustible or limited combustible requirements. The challenge there is wood is combustible. And how do you make wood limited combustible? Well, you don't, is really the answer that comes out of that. So on the prescriptive basis, it would seem we should not be building these tall wood buildings. However, if you go to the US, they are absolutely building these tall wood buildings. So the reason they've moved that way is we've moved to a more performance-based approach where they've looked to offset the concerns that develop when the building gets taller by adding additional systems, sprinkler systems, fire alarm systems, evacuation systems to that. The argument out there is you can always increase the mass of timber, and that and the char rate will do a lot to help at least some fire safety. However, these glued products have that separation concern. So that same fire resistance that you develop by increasing the mass of the timber is actually lost when you glue the pieces together, because now the glue is the failure point, not necessarily the timber itself. And this was seen as how that adds to the fire condition. So if you had a just solid piece of wood and you allowed it to burn, it absolutely would just char and develop an insulative layer that protects the wood that's underneath it. However, when they used these in full-scale fire tests, they found that if the fire was limited by the amount of ventilation in there, it didn't necessarily increase the intensity. Why? Because you can't get more oxygen into the compartment to get it to burn. However, outside the compartment, where there was more oxygen, the fire had a larger intensity. So the physical compartment itself may not be as much of a concern, but outside it certainly is. And then this exposed fuel can certainly add to fire duration. So your traditional fire curve, which lasts roughly an hour or two, depending on what you're trying to test it to, can now be extended out considerably. And then the red line on the slide up there shows one of the more concerning things for me, in that the delamination, or when these materials separate, they actually break off brand new material that can burn. So it's essentially like if you're operating your wood stove and you throw a brand new chunk of wood inside the stove, that's going to ignite immediately, right? Well, the same thing they were seeing in these compartments. When that delamination occurred, the compartment already had enough energy in it to go back to flashover. So you see in a decay phase where you're normally dropping off the energy produced by the fire, this delamination of the wood is going to increase that, that fire intensity, reaching a secondary flashover. Why is that a concern? Well, most of our fire resistance tests assume a consistent fire that drops off at the end, not a fire that peaks and then drops off and then peaks again. And that's going to cause a very different behavior of that fire resistance material as you go that direction. Talk quickly about the photovoltaic systems. I think we've hit the hazards of these particular systems. There were 2 research projects done by the Fire Protection Research Foundation that looked at not necessarily the hazards, but how you get rid of some of the fire hazards that are associated with these systems, be it the fire service suppression or some passive means in there to take care of the fire suppression. The two things that really came out of these studies that stood out to me was that there was an issue with the ground fault protection on them. And it was identified pretty early in the study that 2 major fires in the US resulted because of a ground fault issue. They were using a fused-based ground fault protection, which intended to, once a ground is created that is not intended to be there, the fuse is supposed to operate and it's supposed to prevent the electricity from flowing through the system. That wasn't happening, so the ground would lead to a fire and it causes 2 major lost fires. That's excellent to put into research. It actually got incorporated into the standard, but it did take quite a while for that standard to get published and now also be incorporated into law. So throughout that time, we had this gap of those materials and being installed. The other piece Wojciech hit perfectly is the flammability of the panels. The panels aren't flammable, the roof isn't flammable, but when you put them together in a nice sandwich method and you provide the optimum flow of air underneath to cool the panels so the panels don't overheat, if you know anything about fluid dynamics and fire behavior, the optimum cooling area happens just to be the optimal heating area as well. So if you get a fire in there, you get the 2 materials to play against each other, and there's that re-radiation of energy, and that's a considerable problem. So those 2 problems are not addressed really well in the codes and standards yet, and they do need to be addressed in the implementation of those codes and standards. One things we have, at least at NFPA, put a considerable effort into is a standard on energy storage systems itself. So that's one of the things that we can talk a little bit more about today. What are energy storage systems? Anytime you want to use energy for the future, you have to store it somewhere. They're made up of the batteries, the controllers, and the HVAC systems that are needed to cool off those systems. The hazards are fire, explosion, chemicals, all kinds of other things that you can put in there. No big deal, right? There's a standard out there, NFPA 855, that deals with the installations of these energy storage systems. It's referenced by the NFPA 1 Fire Code, NFPA 101, the Life Safety Code, and NFPA 5000 in the Building Code. And it's applicable to most energy storage system types. However, like almost all standards, it is a consensus-based standard, which says if you're going to install a lithium-ion-based energy storage system, that the standard is applicable when you have a system above 20 kilowatts, unless it's in your house, and then it's only if it's above 1 kilowatt. Why are those numbers in there? That's a really great question, and none of us have really answered that question effectively. However, it's something to think about. One of the things I like to point out, though, is just because the applicability section of a standard says it's only designed for that particular instance doesn't mean there isn't helpful information in that standard to be able to address your problems. Just because that standard is not law in your jurisdiction doesn't mean it's not worth at least a quick read to determine if that standard is going to be able to help the particular situation you're looking at. If we can take a look at these standards in that method, we're at least touching the baseline of some of those instances to understand that we're starting from somewhere, right? We're not starting from zero in all of these. What does 855 cover? It covers the connections of the system, the commissioning of the system, how they're supposed to operate, the maintenance you need to do on them, decommissioning, which is a really big thing when it comes to these energy storage systems. What do you do with it? How do you get rid of the stranded energy? It covers the different types of storage systems, and then it certainly looks at them in 1- and 2-family dwellings. Quick anecdotal thing is I actually have an energy storage system in my house, and I'm actually quite happy with the energy storage system in my house. However, it's not in my basement. It's in my garage, which has a fire resistance rating separating. It's installed on a concrete wall in my garage without flammables around it. My house is fully protected by an automatic sprinkler system, and all of my family know to leave the house when the fire alarm goes off. And my 5-year-old has managed to make this abundantly clear when I am cooking, because he will run out the front door as soon as the fire alarm goes off. But all of those things together are part of that baseline, right? They're not things that we needed to know. Those were things we knew already. We're just now incorporating that in this particular standard. A few of the other things that are in the standard, not as prescriptive based, but as additional references. I'm sure most of you are familiar that NFPA standards have annexes associated with them. The annexes aren't necessarily part of the law or not adopted in or incorporated into the law unless specifically done so by the area. That doesn't mean they're not applicable. And this one in particular, they put in some considerations for the firefighting operations, which is an excellent thing just to read through as a firefighter that may have to address these. It doesn't necessarily mean that they're going to tell you the exact standard procedure that you should use to go to fight these fires, but at least what the considerations are when you're there. The other thing this does really well is it gives you the hazards associated with the system, or at least there's a description of the hazards associated with the system. Again, giving you a baseline at what your fire safety goal could be, right? So if you know fire is a hazard and explosions are a hazard, you can work an engineering solution to that, but you do have to know what that baseline is and expect it to happen. I'm going to hit quickly on some combustible facades. What is a combustible facade? It's anytime you put something on the outside of the building that's going to burn. Usually they're a layered approach. We'll hit that perfectly, and one of those layers is an air cavity. That air cavity we just talked about for solar panels. When you optimize the cooling in the air cavity under a solar panel, you also optimize the heating when it's on fire. Conveniently, the air cavity in the vertical sense does the exact same thing. If the air cavity is too wide, it doesn't provide good cooling inside the building. If it's too narrow, you don't get enough airflow. The same can be done when you're talking about fire, and they happen to be very similar. So that's where your things are pulling in opposite direction. They obviously cause fire spread up the outside of the building, ultimately to the interior if there is enough openings. Traditionally, there's not active fire suppression in them. They've started due to exterior sources, so you have rubbish on the outside of the building or even vegetation on the outside of the building, which causes a fire, and that goes up the outside of the building. But they've also started because of a fire in the building, which comes out the building and ignites the facade on fire. So they're certainly a concern, and when they get on the taller buildings, the bigger concern is we don't have water streams that reach them, right? So you can't get them there. There is a standard test method on that at least we have at NFPA. It's referenced by NFPA 5000, the building code. It's a two-story full-scale test that looks at exterior fire spread. And again, this might not be the absolute answer, but at least looking at what the question is that they're trying to answer by the standard, we might have a better opportunity to understand how we can at least look to protect against these. Here's a photo of the setup of the standard. It's 2 stories. There's a window opening. On the first floor, there's a fire ignited via a burner on the inside, as well as a burner above the window. They're turned on for 30 minutes, and then you observe for additional 10 minutes the behavior of the test. Passing the specific standard means that you don't get any flame spread outside the red line that's shown there, so it doesn't go above 2 stories, which happens to be roughly 3 meters above the window, or you don't get flame spread laterally for more than 3 meters, or 1.5 meters on either side of the center line. And there's no flaming in the second-story test room, and the temperature in the second-story test room is below 280 or so Celsius there. There is really specific language in the standard there about what it means to have flame spread, so it's tied to a temperature correlated closely to the temperature of a flame. But at least this understanding that the goal of a compliant material was if a fire was happening inside the building, that it wouldn't go up the outside of the building now as a standard. Does it mean it needs to be incorporated everywhere? No, it just gives you an idea of where you could look to as you're developing these standards. After Grenfell, they put together, in the US at least, a tool that helped identify the facades that were of a concern. It's an interesting tool to at least kind of move your way through. It is very US focused though, so it's hard to apply in all the other areas. But it looked to, you can take away from it not necessarily the prescriptive items that are in there, but just the process itself, that it was looking to prioritize buildings or allowing folks who were responsible for inspecting buildings to prioritize the one in their jurisdiction that could be a problem, take and look at a basic fire risk assessment to these. Are they a problem? Are they not a problem? And identify the ones that you need to have that highest priority at looking at. Because we know there are combustible facades out there. We know they're getting installed on the outside of the building. How do you identify them and what do you do about them? This at least gave you a roadmap to start that process and how to move in that direction. So I want to go through a little bit of the standards development process and a case study, and then after that we'll talk about the concept of the fire and life safety ecosystem. And I've got about 15 minutes to finish up without questions, so I'm going to see how well I can do here. I am paying attention to the time again because lunch is incredibly important. So the standards development process, let's look at a quick case study. So I'm sure some of you have heard of the Triangle Shirtwaist Factory fire. It occurred in New York City in 1911. On the upper floors of this high-rise building, they had a shirtwaist factory. The name is very deceiving, much like the National Fire Protection Association. Shirtwaist was not the stuff that is left over after you make shirts. It happened to be the particular type of shirt they were making. So they were designing a blouse, a woman's blouse, and there was all kinds of sewing and everything going on up there. They were very concerned with the workers leaving early, so they locked one of the two exits, so you had to pass the foreman on the way in and the way out to make sure you were ensuring that you were leaving on time. There was a fire escape installed on the outside of the building, but it collapsed during the evacuation, actually causing several people to fall many floors. There was no active fire alarm and no fire suppression in the building, and 146 people were killed. Most of them actually from jumping out the upper stories of the building. As you can imagine, this caused a major uproar in the fire safety community in 1911, right? We should have buildings that are safer than this. So how did we address it? Well, the fire occurred in 1911. There were some codes developed and incorporated into law in the city of New York. However, outside the city of New York, it still wasn't necessarily mainstream. In 1913, so 2 years later, at the annual conference of the National Fire Protection Association, one of the witnesses to the fire actually came and testified that and challenged the National Fire Protection Association to develop something that makes things more safe in these particular buildings. What did they develop? They put a committee together, that's what I always do, on safety to life, was established in 1913. It took 3 years for them to come to a consensus to publish their first pamphlet. That's not even a standard, but it had information on how outside exit stairs and fire exits should be in buildings. And it gave that baseline. It's not necessarily a codes and standards, but it disseminated that information. 2 years after that, they published a pamphlet on safeguarding factory workers from fire. And then it wasn't until 1927, so 16 years later, that their first code was actually developed, which is now known as NFPA 101, the Life Safety Code. The current edition is 2001, where actually the new edition comes out this year. Some may point out my timeline didn't go long enough, but if I made my timeline long enough, you wouldn't be able to see what the actual challenge was here. But that 16 years is a long time, right? Especially in our built environment now. The challenge was in 1911, it wasn't that long of a time. We weren't building buildings as fast as we were building them now. We weren't innovating as fast as we are now. So this has been amplified. But have we worked to make the process of those codes and standards development easier? What does our codes and standards development look like? Well, it's a 3-year process that is very open. So if anyone is interested in participating in the standards development, we have a way that you can apply to join our technical committees, but also any public is allowed to comment when there is a public input stage open. And that is actually the first thing that happens in any of the either updates or creation of new standards is the public input stage. After the public input stage, they go to what's called a first draft meeting where the committees will sit down, they'll look at the draft that was produced, and they will vote on each item one by one, and the majority rules and of that first draft, and that produces a report that has that first draft report in it. They'll go out to a second public comment stage and do the meeting and the voting all over again. And after a 3-year process, that eventually makes it to the NFPA technical committee, where it can be voted on and become a standard and be published out there. Once it's published, there are ways to change it. So if there are things that come up that are absolutely a concern, there's appeals that can go to the Standards Council, which will allow them to evaluate whether the code or standard needs to be looked at in between that normal 3-year cycle. But it's still a 3-year process. And we stand behind this process quite a bit because it opens it up to public comment. It allows it to be consensus-based. Don't want to go into too much, but we limit the committee's representation. So you can only have a certain number of manufacturers. You can only have a certain number of firefighters. You can only have a certain number of fire safety engineers on each of the committees. So you hopefully get a well-rounded representation of them. But still, it's a process, and it takes time. And even after the process occurs, these now need to get incorporated into law, and that even takes more time, because although ideally we would like it if you incorporated the standard as it was developed into law immediately, most of the time it gets read through and then it becomes a political discussion on which pieces of the standard need to be incorporated into law and which pieces do not. So there's a time frame that goes through all of that, and that time frame is something that we need to consider as we're looking at these sustainable initiatives that are coming out that are going incredibly fast. They almost cannot keep up with this. So the challenges is this standards process is often driven by a major incident, right? So something happened that we said we needed to not have happen again, so we are going to look to implement it in the standard. It takes time to develop, time to incorporate into the law. It's usually a historical look, because most of us don't know it's a problem until there's a major incident, which is a huge challenge, because a major incident doesn't necessarily happen right after a new technology or a new innovation occurs. It takes time for that to happen. And I would say the evolution of building materials and practices has threatened to outpace it. It probably has outpaced the development of it. But there's not much you could do to speed it up and still keep it as a consensus-based standard. So that brings us to an item that we came up with about, I think, 4 years ago, which is the NFPA life safety ecosystem. So instead of looking at things through the lens of a code or standard, we wanted to look at fire safety through the entire ecosystem that needs to be around to make buildings safe. And that ecosystem was made up of a ton of individuals and a ton of organizations. And we identified 8 major components that looked at having a role in protecting people and property. And the top of it was government responsibility, meaning the government needs to at least identify a baseline of where they want to be and work with at least the folks doing the building to be able to establish that baseline and make it well known. Then there is the development and use of codes and standards. That's an incredibly important piece, whether it's a consensus-based standard or it's a research-based standard or it's a hybrid of those. That develops that baseline that we were just talking about today and how we use it. But if we don't, if the government doesn't look to those to develop their baseline, then it can get a little bit skewed and it causes a challenge in that ecosystem. The reference standard cog, the reference standards are even more important sometimes, or just as important as the codes and standards, because the building code doesn't necessarily tell you how to test a material to ensure that it has a 2-hour fire rating. But it does say that certain walls need to have a 2-hour fire rating. So those standards that tell you how to test to a 2-hour fire rating are a reference standard in the building code, and they're just as important in both development and incorporating into the particular laws. So the next cog was an investment in safety, and this is the money piece. And I know Ricardo talked about this several years ago when I came to the Congress when I was working for UL, but we need to have an investment in these safety pieces because it costs money to do the research. It costs money to develop the codes and standards. And we need to invest in those items, and you have to invest in all of the cogs to ensure that you're going to make the safety that you're looking for. A skilled workforce is a huge piece of this ecosystem. So PV panels is a perfect example. The statistics earlier today showed that the installation was part of the problem the vast majority of the time. So how do you develop a skilled workforce? Well, you have to invest in that knowledge that the skilled workforce is going to have, and that costs money. Code compliance is a big piece. How do you have code compliance? Well, you have to have the code first, and then you have to check to it. And if you're not checking to it and having that back and forth, it's very difficult to keep that ecosystem together. Preparedness and emergency response is absolutely a piece to this. And the key there is it's both preparedness and emergency response, right? Preparedness happens before the incident, and the response happens either during or after. There are ultimately going to be things that challenge your safety ecosystem wherever it is in the world, and you have to identify that worst case. But if you have a prepared responder force that can at least isolate it. Now, what does isolation mean? That's a great question. Does it mean isolate it to the item that was burning? Does it mean isolate it to the room that's burning? Does it mean isolate it to the building that's burning? Does it mean isolate it to the block that's burning? Or does it mean isolate it to the city that's burning? Those are tough questions to ask, but those are questions that we need to incorporate into the ecosystem, because that also all plays against what your investment in safety is and what your minimum level of codes and standards should be. The next piece is an informed public, and this is also highlighted very much so when we're talking about the e-mobility devices. So if the public doesn't know that something is a hazard, they will obviously not treat it as a hazard. A great example of this is 5 gallons of petrol or gasoline, right? It's a common size can in the US. Where do we store the 5 gallons of petrol or gasoline at our house for our lawnmower or whatever device we're going to use it for? In our garage, in our basement, in our shed, right? But we have identified that we are not going to put that at the entrance to the house, right? You're not going to walk in somebody's door and there'll be a 5-gallon can of petrol there. The public knows that that's enough of a hazard that they don't store it in their bedroom. The vast majority of them don't store it in their bedroom. But do they know that the e-bike or even the battery in the cell phone is a hazard? And have we shown how that hazard is relative to something that they do know what the hazard is? And that ties back to our investment cog. You have to have an investment. It costs money to educate the public to do it. It goes up to our government responsibility. They have to help in that investment and inform those public to make sure. So all 8 of these cogs really need to work together to develop a level of safety or whatever ecosystem you're looking at. They look very different in every country. They look very different in some regions. They look very different in some cities. But having the holistic piece together allows you to put a level of safety to them. One of the big pieces that stands out to me in this is if you develop an ecosystem of safety, you don't necessarily have to look to the failure of one item when something occurs. So if you have a major loss fire and you have developed your ecosystem, more than likely several items in your ecosystem had to fail or not work as intended for that fire to occur. So that'll make that loss as at least less probable of occurring. It doesn't mean it's going to eliminate it completely, but it'll make it less probable of occurring, because in the event that code didn't address a particular item, a prepared response force was able to keep it to the room or the building of origin, and we're not as concerned about it. Now, that room or building of origin may be a different concern when you're talking about a high-rise building, because leaving it to the high-rise building or confining it to the high-rise building is probably not the safest method that we have out there. But at least playing those off each other can allow you to have that. So I really like the ecosystem concept because it allows us as fire safety engineers to approach these things, and really we should have a part as fire safety engineers in each one of these different cogs to be able to work together to be able to develop the baseline level of safety that we're acceptable, or that is acceptable to our particular locale. So that's all I had today. I did stick to my time. I left about 4 minutes for questions, and then we can still get to lunch. So thank you very much again for having me out here. I'll be here the rest of the day. I will be here the rest of the day if you have questions that come up. Unfortunately, I won't be here tomorrow, but I'd be happy to answer any questions that come up today or any questions that we have now.
Is everybody hungry or still people thinking about having a question? Anybody? Niels.
Thank you for this. Thank you for your great presentation. I was a little bit wondering about this sort of democratic process of developing the codes. We in our institute, we have a sort of baseline that we do not say participate in democratic code development, is it? You? Yeah. We think it's a sort of, dealing with pluses and minuses and then some sort of middle solution comes about. But you have it as a sort of baseline how you develop your codes in your country, and what's your experience with those sort of dealing with safety with all kind of parties and pluses and minuses?
It's a challenge. It is absolutely not easy. The folks in our organization at NFPA, they're called their standards leads that lead those committees, are constantly faced with those challenges of how you can go about those. One of the positives to it is you get a lot of buy-in if someone had participated in developing it. However, the opposite is true as well. If they didn't have participation in it, they don't have as much buy-in in it. So it is absolutely a challenge. It's what's worked for us and has worked in our country for 125 years. Will it continue to work? I don't know, because you have to address the problems that come up. And if the process can't be fast enough, we may have to develop the process to look a little different to make it faster. Or we may have to look at other pieces of that ecosystem to make up for the fact that some of those processes aren't going as fast. The bigger challenge I see, and again, it's just our US perspective of it, is if we aren't looking at it as a consensus thing, we have that opportunity to go for the perfect. And when we go for perfect, over 80% or even sometimes 60%, we always often never accomplish anything. So at least in this instance, they're required on a time scale because our code has to be updated every 3 years to at least meet that time scale. So it does have that benefit to it, but without that time scale, you could research and research and research and research, but applying that becomes incredibly difficult, especially if you're researching something that's evolving faster that you can do research. So, but thank you. Excellent question.
You have to go a long way. All the way up.
Speak loudly. It's all right.
I will run.
The clock in the back says we got 1 minute, so I'll answer the question very quickly.
Good morning. I would like to add something on what our, sorry for your name? Niels said about codes and so on. There's one aspect we did not talk about yet so far, but what about fire detection methods? Is that also something for the NFPA?
Oh yeah, we have an entire standard, NFPA 72, on fire alarm and detection systems. There is an incredible amount of research that's gone into detection systems in the US and making them as effective as they can be. Again, it is one piece of the puzzle though. Our codes are very layered approach. Detection is there to alert you of an incident. It's not there to protect the building. Fire sprinklers are there to protect the building. When you layer those together, the sprinklers may give you more time to get out, and the detection allowed you to know that you needed to get out first, and that allowed that all to work together. But it's a huge piece of ours. I'm not actually 100% familiar with how much you guys use NFPA 72, but it is the equivalent to the sprinkler standard, but for fire alarm systems. So it has all that detection pieces in there. And just like a sprinkler, where you install the smoke detector really matters, where you install the heat detector really matters, and that standard kind of lays all out those different instances. But you got to keep in mind that standard was also developed on responses to incidents, right? So a smoke alarm was in a smoke detector was in a building and it didn't go off. And we had to figure out why it didn't go off, and then it got incorporated into the standard why you would need to adjust that. So that is still part of the challenge, but it's certainly in there to exist.
I think nobody really dares ask another question because we're going to lunch. Robin, thank you very much. Robin Zevotek.
Thank you.
Before we go to lunch, thanks to all three